Okay, so last time we were talking about addition, subtraction of whole numbers, and we left off on kind of having discussed all the addition components of what we talked about. We talked about properties for addition. We talked about models for addition, the set model, the measurement model, and we're going to talk about the models for subtraction next. And there are more models for subtraction than there are for addition, and so these are spaced out a little bit more. And the kinds of things that I would like for you to sort of take away from this is that there are different models. Think about word problems and whatnot. And while they're all subtraction, our minds work differently when we think about them. And so some children, if you can identify that the problem is that every time they see a problem that's a comparison model, they get freaked out, then maybe you could actually address that issue and deal with that kind of problem. The issue is maybe not about subtraction, it's about how subtraction relates to this context. That kind of thing. So you need to be aware of the different contexts in which these can be used. All right, so here's the first one. It's the takeaway model. It's probably the most popular in terms of what we would, describe subtraction to be. So you know what a subtraction is. You say, well, you have some stuff and you take some stuff away. And that's sort of our mindset about that. So first of all, subtraction is defined in terms of addition, and that's the definition you see on top. So if you've got a number A and it's bigger than B, then when you take A and you subtract B off, then it's equivalent because, or it's equivalent to describing this as that B equals C, B plus C equals A. So we're writing it in terms of addition. So here's the takeaway model, which is where I was headed. So Abby, my daughter, she does collect rocks, okay? Like the pretty ones that you buy in the zoo. Really shiny purple and that. So she has 24 rocks, and Eli sneaked into her room, which is very fitting because this is something he would do. And he takes some of her rocks away. How many does she have now? So I'm going to draw a picture, too, of what this is going on, and so that you can see a set model picture. And I probably should have chosen a number smaller than 24, so I don't have to draw 24 of these little guys, but we're going to do it anyway. So I've shown you guys the infinite cloner, right? Okay, so we're going to use M. Did I do it before you guys finished drawing? Why didn't you drew them? You didn't draw 24 little circles on them? Yeah, there's nothing that you can do infinite cloner on your paper with. All right, so we have 24 circles, and let me actually extend my page a little bit. So the idea would be that this is your set of items. We'll talk about sets. So there's 24 rocks inside of there, and Eli sneaks in and he takes 5 away. So the image that you have is taking these and removing them from the sets. So this is the image of what's going on. You actually are removing something from something you have. That's why I need to circle around, because I need to be able to draw this arrow to be able to show them taking it away. So imagine that's the taking it out of her room business going on here. And then of course, this means I've got 24 minus 5, and we can do that also by counting what's left on the inside, and we would get how many? 19. For what it's worth, when I originally wrote this problem, there was more than 24 rocks, so I did decrease the number of rocks. All right, so this is the takeaway model. Now, the next model is called a missing add-ins model, or sometimes called missing parts. And there's lots of pictures for this too, and I'm going to show you a couple of different pictures. One is one that I have seen recently on paperwork that my daughter's brought home and is also represented in your book. Another one is also represented in your book, and I've seen them before on work that comes out of the first through third-ish grades that come in there. And so this is missing addins. So if you have an example like this, so Eli needs to collect 10 leaves for a project. He and Abby go out, they find 8 leaves. How many more leaves do they need? Okay? So I'll draw the picture first that your book mostly draws. Okay, so we need 10 leaves, but we only have 8. So we draw the 8 leaves we have. Okay, so those are all leaves, just pretend, and I think I drew 8 of them. So what's missing then, in order to make it 10, is you're missing 2 of them. So the 2 that are missing, what you do is you draw them sort of as dotted in there, or you can draw Another way that they did it, I've seen them do it a couple of ways. I'm going to draw it the other way too. You can draw it as sort of like a circle inside here. The question as to what goes in the circle is missing. How many are missing to complete the picture to make it actually equal to 10? Okay. This is one way of drawing it. Another way of drawing it, and this is almost kind of like a measurement sort of thinking, but it's usually done with a box. I shouldn't draw my line, but more like a box. So they say something like this, that this box is 10 long or something like this. And they split it into pieces, and they say this is 8, so how much is this piece? Have you guys seen this before? And so the question mark would go here or something like this, and we would fill that in as 2. This is a really nice description, this idea of missing addends, of what leads into algebra. Because you see, you can write this down. And again, you see this written sometimes on children's work when they are working at this level. You see a blank spot or a question mark. You don't see an X there, right? But that's what we know it means later on when we get into algebra, right? We would put an X there as the missing piece. And the other thing that this does, which is really nice, is it hopefully starts to remove from our children's minds that equals means tells me the answer. Because I still have students coming in, and some of you probably are some of them, who have this idea that equals means this is my answer. And equals doesn't mean that here, right? I mean, these are two things that I've got on each side, and the part that's my answer is not what kind of math with the equals sign. It's actually the board on one portion of the part, or one part of the picture. So, of course, the answer to this is 2, yeah? So 10 minus 8. Look at this all together. Let's try again. 10 minus 8 equals to 2. So you've got a couple of different ways to draw pictures for missing addends. Okay, comparison. And comparison is one of the ways of subtraction that causes concern for children, okay? Because you're not actually taking anything away, and you're not finding something that's missing, which is what you mentioned before. What you're doing is you're comparing two different equivalent objects, or the size of them, or the number of them. So we've got Jessica and Jeremy. They play basketball. Jessica scores 12 points, and Jeremy scored 8 points. How many more points did Jessica score than Jeremy? So when you guys read that, I'm sure you read that and say, well, I just need to subtract 12 minus 8, right? But why? I mean, well, why do we subtract there? What is it about that that sounds like subtraction? Because it didn't sound like the other two examples that I just created, does it? It really doesn't. It doesn't sound the same at all. So let me draw you a picture model for how you can describe this. And again, these work really well when we're first establishing with small numbers what it means to subtract or to add, right? My example with the 24 rocks was a little excessive because I had to draw 24 little rocks, okay? So I'm drawing something that I can draw in a small amount of time. I don't need the number 256 because I'm not going to be able to draw that. I was talking the other day actually to someone, and I was saying that there's these two components that are both equally important when you're teaching mathematics to young children. There's the component of understanding what we're doing, understanding why this process works, okay? And that's really important. We want them to understand why this is subtraction, okay? There's also the component at some point, which is, I don't want you to have to draw a picture every time you have to figure it out. At some point, you need to be able to just know that 12 minus 8 is 4. Yes? Same thing for multiplication tables and whatnot. But they're both equally important facts, right? Just knowing 12 minus 8 is 4 and not knowing why in the world that works is really unhelpful as well. So for this stage, we're at the first part of the stage, the understanding why it works stage, okay? All right, so we've got 12 points, so I'm going to draw them as hash marks. So there's Jessica. After that, write her down. And we're going to do Jeremy next. And so Jeremy has 8 points. So I'm just going to draw them. I'm going to draw them so that they're lined up. That's important. So whether you're drawing stick figures, whether you're drawing squares or circles or whatever it is you're drawing to represent them, in order to compare, they got to be one on top of each other. Okay? So I need to draw Jeremy's 8, but they need to fall under the very first 8 of Jessica. So what you're seeing is that these 4 right here at the end don't have any that they are compared with down Jeremy's line. Make sense? So that's telling me exactly how more by pairing them up one-to-one, kind of like that one-to-one correspondence we did in the last section. You guys are doing those? This is what we're doing here, right? We're doing a one-to-one correspondence in picture form. And we're seeing how many are left out of that one-to-one correspondence. So this portion right here, the 4, is what we get. So we have 12 minus 8, this 4, and this is the picture form or model that would represent that description. Okay. Number line is tricky. Yes, Beth?
On the test, are you going to like the answer to be 12 minus 8?
Did I write something down wrong?
Or just...
What am I writing down?
Just like, is that what we're going to need to circle the whole equation?
Well, first thing is, let me tell you that I should have put points here. That was sloppy. So the answer is just 4. I don't have to see the 12 minus 8. Your picture actually supports that. So I think that's what you're asking me, isn't it? Whether you actually need to write down the 12 minus 8 part, you wouldn't have to. All right, a number line measurement model, can follow any of the other 3 sort of pictures that I just took for. It can be taking things away, it can be comparing, or it could be doing this in add-ins. But it's usually doing it with something kind of like we did last time when we talked about measurement model, something that actually could be broken apart into fractions. Okay? So, for instance, you can't score half a point in basketball. So it wouldn't make any sense to compare points in basketball in a number or measurement kind of sense. Does that make sense? I said the word sense like 3 times there. But, you know, that's what's going on. So all those 3 other models can be sort of bled into the numerical or the number line sort of picture. It's just that when we're doing number line, we're comparing or we're taking away or whatever something that could have been broken down. So for instance, miles, right? You can draw and you can talk about walking or riding or whatever half a mile, and that makes sense. And so in terms of drawing the number line for that, it's a really good visual representation of what's happening. All right, so we've got Luke, and Luke drives 15 miles to the mall. As he's on his way home, his mom calls to ask where he is. He states that he's coming home, and he's now 8 miles from the mall. How far is Luke from home? Okay, so let me draw you a picture of what's going on here. So the picture is a number line picture. So we've got this, and it starts with him being at home, and it's 0. And he ends at the mall at 15. Here's 15, and this is the mall. It's a terrible 5. Hang on. Okay, so we've got Luke, and he's gone to the mall, and there's a 15 I need to erase over here. Where'd that go? Okay, so we talked about last time the fact that unless you're using a different color, or if you want to draw really bold, so it's easier to draw the line on top of where you are, right? So you just have a little bit to see it. Same thing's true for subtraction. So what we've got is we've got Luke, and you know, let me do this. Right, didn't mean for it to be so thick, but you get the idea. All right, so here's his 15 miles that he goes to the mall, and make sure I'm drawing the same way that I drew. You can draw an arrow on the end of this to indicate that he went there, whatever. It should be all bold, but it's not. And then he's going to return, he's going to go back from the mall, what did it say, 8 miles? So he's going to return, he's going to go back this direction 8 miles. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Means he ends here when his mom calls. So how far is he away from home? How far has he still got to go? Yes, he needs to go 7 more miles. So this is a picture that you would have based on a number line or measurement model, and the answer would be 7 miles. Okay, make sense? All right, what I would like for you to do next is just right where you are. I don't want you to get into your actual group. So right where you are, I want you to group with somebody you're right next to, okay? And I want the 2 of you, because I think that you have an even number, you're doing 2, 4, 6, 8, 10, 12, 14, 16, even number is awesome. I want you to come up with 4 different models, okay? One for each of the 4 types. Okay. Missing add-ins, takeaway, measurement model, and comparison. Okay? So, go ahead and take a few minutes to do that, and then we will finish up our one more last slide. Yeah. All right, so you're going to have created, you've now created word problems for each of your 4 models. So can one of your groups tell me the example you used for takeaway? Who wants to go first? Kayla? Okay.
Kayla had 5 scarves. The chairs came in her dorm room and borrowed 2. How many does she have?
Good. Another example. Rachel.
Charity has 10 pretzels. Rachel eats 3. How many pretzels does she have?
I find it very interesting that you guys are using each other's names.
We didn't. We used to.
You use family members. Okay. All right, let's do missing add-ins. So if you've already talked, your group's done. You don't have to talk again for missing add-ins. Missing add-ins. Another group for missing add-ins.
Beth needs 10 pennies. She finds how many more pennies does she need?
Perfect. Jordan, did you guys want to do it too? Okay.
Jordan is making cookies for her 15 friends. She makes 11 cookies. How many more does she need?
Awesome. All right, so we have 2 more, and I think we have 4 more groups. I think there's 16 of us. So, comparison. Who wants to do comparison? Yes.
Steve has seen 5 movies in the last month. Jimmy has seen 2. How many more has Steve seen than Jimmy?
Awesome. That'll work. Who else wants to do Katie? Okay, Katie, do your comparison.
David and Ryan play soccer. David scores 3 goals and Ryan scores 5. How many more goals does Ryan score?
You guys want to do the number line? You guys are working hard on this one. Let's see what you got.
Okay, Emily walks 14 miles to school. Her friend meets her 8 miles from the school. How far does Emily walk alone?
That's good. That would be an uphill.
Uphill in the snow.
All right, Caitlin, can you or Megan tell us what you guys do for number line model?
Okay. Caitlin used 4 gallons of gas going to the outdoor learning center. She has used 2. How many gallons away is the outdoor learning center?
Say that again.
Caitlin used 4 gallons of gas going to the outdoor learning center. She has used 2. How many gallons away is it?
So you said twice that she had used gallons of gas, and then you said how far away, which we terms in miles. I'm not sure why you got what you want. Let's fix it. Let's fix it. Let's fix it. So Caitlin, when you said that you've used 4 and then you've used 2, what do you mean? Like it normally takes?
Like it takes 4.
It takes 4? Okay, so it takes 4 gallons of gas to get to the outdoor learning center. And you used 2 gallons of gas. That makes more sense now, right?
How many more gallons?
And then we want to talk about how many more gallons she has left to go or something like that. We don't, yeah, we want to make sure that the answer that we're getting is still the same units as what we were talking about before, right? Yeah. All right, sounds good. All right, we're going to do one more thing in this before we do group work, official group work. All right, we did properties of addition last time. You guys remember? These were them. These were the 4 properties of addition. And we want to know which of these 4 properties for subtraction hold. Okay? So, closure property. Closure means what? Can somebody give me a description?
We subtract 2 equals 2.
3 plus 5 equals 8, meaning what? What happens when I take 3 plus 5 together? Another whole number. So the closure property for whole numbers means if I take 2 whole numbers and I add them, I get another whole number. So the question is, does that work when I subtract?
No.
Can you give me an example of why not, Kayla?
Well, if you have 5 and then you minus 8, which are both whole numbers, then you have a negative number, which is not.
Oh, how about this?
Oh, look at you.
Let's go to symbols now so we can use them. Yeah, that is not a whole number. 5 and 8 are whole numbers. And when I subtract them, I do not get a whole number. So could I have created an example where I did?
Yeah.
Yes, but that's not what I really need. I need to make sure that all examples will work, correct? Okay, how about commutative?
No.
Kayla says no again. Caitlin as well. Yeah.
It's just like that problem.
Okay, so can you tell me what I could do, Anna?
Like if you did 8 minus 5, it equals 3. But if you did 5 minus 8, it's a negative 3.
8 minus 5 is not the same as 5 minus 8. And this one's even better because I could pick just almost anything, maybe. Yeah, with the exception of the same number itself, like 8 minus 8 would work. But aside from choosing the number and itself, any number I pick is going to make this fail. So that's actually an easy way to find a counter. That's what you're doing. These are counter examples. You guys remember that from chapter 1? Give me those faces. How about associative?
Isn't there
No.
only parentheses?
It is one with parentheses. Can you give me an example?
8 minus 5 minus 3.
Okay, do you mean like this, Lauren?
Yeah.
Okay.
39.
And you think that that's not going to equal what?
8 minus 5 minus 3.
Right. And so we want to actually verify that this is a correct statement, that these aren't equal, because, yeah. So what is 8 minus 5 here?
3.
And then 3 minus 3 is
0.
0. So this is 0 on the left. What's 5 minus 3 over here? 'Cause that's 2, and then 8 minus 2 is 6. So this will work. You do have to be a little bit careful with associative property because you could inadvertently pick something that actually did work. It's a little bit easy because this is a possibility here, okay? It's not quite so possible in commutative property. What? Identity property. Got somebody else saying no. What is wrong with all these properties? Okay, so give me an example.
Well, 1 minus 0 would be the, like, negative.
Okay, so 8 minus 0 would work just fine, right?
Yeah.
But what's the problem then?
0 minus 8 is negative.
So the identity has to work in two directions. I don't just get it in one direction. So every property that we dealt with for whole numbers in addition fail for whole numbers with subtraction, don't they? That's problematic. All right, so that's going to come up a little bit on your homework, but I wanted you to have some sense of what they're doing with this. Okay,